Hello, and welcome to STEAM Camp. My name is Mrs. McDonald, and I will be taking you through our activities for the day. Today is Thursday, and our focus will be on math. On today's agenda, we're going to begin with a short introduction. Then, you will get to engineer your own crash test car, which your egg will ride in. You will use math to calculate the force on your egg when it crashes. We will wrap up the day with connections to careers. Let's get started. Today, we are going to integrate math with science and engineering as we explore ways to keep the egg safe during a car crash.
Wait. Yesterday you threw me off a building? Today I'm going to be in a car crash? Can we please go back to nature journaling?
You'll be fine. Probably. You might end up a little scrambled.
Huh?
Please open your STEAM Camp journal to the math section. Take a moment to think about these questions and then answer in your journal. What kinds of things help a person stay safe when riding in a car? And what do you do to help stay safe when riding in a car? You will have 5 minutes to think and write. Turn to your elbow partner, and each of you share your responses to these questions. In today's activity, you are first going to engineer a crash test car with features in place to keep your egg safe.
Oh, thank goodness.
Then, you get to test your car with your egg and finally, using math, calculate the force on your egg when it hits the wall.
Hits the wall?
Yep. You will have specific criteria and constraints that you must follow to build your car.
Oh no.
Don't worry. Having criteria and constraints are what help scientists and engineers create solutions for problems. When we talk about criteria, we mean the characteristics the solutions must have to be successful. Think about when you play a game. The criteria is what you need to do to win the game. For this project, you are working to keep the egg safe. So the criteria for this project will be that your egg must remain in the vehicle after the crash.
So I shouldn't be catapulted from the car.
Catapulted? Great word. But no, you should not be catapulted.
Good.
Constraints are limitations your solution must accommodate. It's kind of like following certain rules of a game.
Oh, like when we play Scramble. The letters you put on the board, you have to make real words?
I think you're thinking of Scrabble.
No, I'm pretty sure it's called Scramble.
Okay, well, the constraints of engineering your car are that your egg must be able to see out of the car. This means that you cannot completely wrap up the egg in the car or cover it with tape. Next, your egg must be able to freely enter and exit the car, just as you would a real car. Third, you can only use the materials provided by your teacher. Finally, you will have a limited time to build. These are the materials you have available to engineer your car.
Ooh, cotton balls. Those are nice and soft. Use lots of those.
Well, students are limited in the amount of materials they can use.
Can we switch out the wheels for more cotton balls?
But then the car won't roll down the ramp?
Exactly!
All right, it's time to build. I'm going to demonstrate how to build the basic structure of your car. You will then have time to come up with ideas for how you want to use the remaining materials. Before we begin, you will also want to have your STEAM Camp journal so that you can record the quantity, or how many, items of each material you use. Step 1. Take one wooden dowel and one of your wheels. Push the wheel into the dowel. Place the dowel through one of your straws and push another wheel through the other end of the dowel. Here's a pro tip. Add 2 small pieces of masking tape to each end of the dowel to keep the wheels from falling off. We are then going to repeat this process so that when you are ready, you will have 2 sets of wheelbases for your car. Step 2. The next step is to attach the wheelbases to your cardboard piece. Place one wheelbase about a 1/2 inch to 1 inch from the edge of the cardboard and tape the straw to the cardboard. Remember that a 1/2 inch or 1 inch from the edge is just a suggestion. You are welcome to try something different. Step 3. The last step to building the basic car is to place the plastic cup, which is the seat for your egg. You will want to decide where the best place is to put the seat. Once you have decided, securely tape the cup to the cardboard. Now that you have the base of your car built, you will want to use any and/or all of the materials you have available to make your car as safe as possible. Some things to remember. Your egg must be able to see out of the car. Your egg must be able to freely enter and exit the car. You can only use the materials provided, and you will have 15 minutes to build the rest of your car. As you build, be sure to add the quantity, or how many, of each item to your STEAM Camp journal. turn to your elbow partner and compare your ideas. Before you test, are there any parts of your car that you want to change? Now that you have engineered your car, you will want to test how well your design works.
Could we talk about this? I mean, no one really thinks it's a good idea to put me in a car and crash me into a wall, right?
Well, we all thought it was fine to throw you off a building yesterday.
Not all of us.
Your teacher has set up 2 stations in your classroom, each with 2 available ramps. The station that has 5 books creates a ramp with an angle of 15 degrees. The station with 10 books has a ramp with an angle of 30 degrees. Notice that each ramp also ends at a wall. This is what your car will crash into. You will have 20 minutes to complete this task. Be sure to record your observations in your STEAM Camp journal. Now that you have engineered and tested your car, you will use math to calculate the force on your car.
No more, please. I have such an headache.
Don't worry. Students will be using brain power from here on out.
Good, because I need a nap.
Eggs take naps?
We do when we've been thrown off of buildings and crashed into walls.
Fair enough. Take a moment to think about this question and then answer in your journal. What do you think of when you hear the word force? You will have 5 minutes to think and write. Turn to your elbow partner and each of you share your response to this question. So, what comes to mind when you think of the word force?
Star Wars.
Okay, but...
I'm a Jedi Knight using the Force to help the Resistance bring justice to the galaxy. And my lightsaber is blue.
Obviously.
Just like Luke Skywalker. And my dad's Darth
in
Vader.
science,
And I'm
when
going
we
to go
talk
with the
about a
Emperor.
force,
And we're going to
we're
all be
talking
happy
about
family
a
afterwards.
push
But
or
actually, we're not
pull
going to be
on an
because then all these
object.
things happen.
When you let the car go, the force of gravity pulled the car down the ramp. It's great that we could actually see it happen. And what's cool is that we can calculate what we saw using math. All we need to know is the mass of the car and the acceleration of the car. Fortunately, we can easily find these out. First, you will need to calculate the final mass in grams of your car. To do that, simply add all of the numbers together in the total mass column. Then, write your answer in the final mass box at the bottom. This is the final mass of your car in grams. To calculate force, simply multiply the mass of your car by its acceleration. In this case, you will calculate the force using the acceleration from the ramp at 15 degrees and 30 degrees. Find the table in your STEAM Camp journal that shows you the acceleration in meters per second squared for each ramp angle.
What are the units for force a capital N?
Great question. That stands for Newton.
Like Sir Isaac Newton, that guy.
Yes. A Newton is a unit of measurement that means grams times meters per second squared. It is abbreviated as a Newton and was named after Sir Isaac Newton for the work he has done to increase our understanding of motion.
They're also delicious cookies, so a Newton can mean a gram times meters per second squared or a delicious cookie.
Well, here it's the first one.
Do you have any cookies?
No. Students, take 5 minutes to calculate the force of your car using both acceleration measurements and record in the data table in your journal. Don't forget to write the units. Great job today. You combined engineering, science, and math to create and test a crash car and then calculate the force on your car. I'm so proud of the hard work you did today. At the beginning of this activity, I asked you what you do to stay safe in a car. Now I want to show you why it is so important to be safe when in a moving car. As you watch the video, pay close attention to the damage to the hood and front windshield of each car at the different speeds. And if watching a car crash makes you uncomfortable, you absolutely do not have to watch.
Whoa, that was intense.
I agree. Let's look at it from a math standpoint. Do you remember our equation for force?
Force equals mass times acceleration?
Correct. Let's calculate the force on the car in the video. First, we need the mass in grams. The car in the video is a 2010 Honda CR-V and has a mass of 2.1 million grams.
Million?
Yep. It's probably why no one can pick up a car.
Well, maybe if they had a lightsaber.
Still, no. Now that we have the mass of car in grams, we can plug in the acceleration of the car at 40 miles per hour, 50 miles per hour, and 56 miles per hour. At 40 miles per hour, the car accelerates at 358 meters per second squared. Putting that into our equation means the force on the car is 751,800,000 500,000 newtons. At 50 miles per hour, the car accelerates at 447 meters per second squared. This means that the force on the car is now 938,700,000 newtons, an increase of almost 200 million newtons.
Whoa, good thing that guy was wearing a seatbelt and had airbags.
No kidding. At 56 miles per hour, the car accelerates at 501 meters per second squared. This means the force on the car is a whopping 1,052,100,000 newtons.
Wait, the car was only moving 6 miles per hour faster than before?
I know, right? Students, take a look at your numbers and compare.
After seeing the math, I guess I shouldn't complain about being in a car crash today.
Well, we thank you for being such a good sport about it.
And I will always remember to wear my seatbelt.
That's great to remember. If what you did today might interest your egg when it grows up, I want to give you a few options of ways to explore careers that involve math. You can choose to do any of the following 3 options. You can explore math careers in a virtual job shadow, get to know a little bit about data scientists, or explore careers at NASA, including becoming an astronaut. Your first option will be to explore virtual job shadow. Your next option will be to watch this video on data scientists. If you are unfamiliar with what a data scientist is, well, they're someone who knows how to find meaning from and interpret data by looking at patterns, building models and algorithms. If you want to learn more, go to the bit.ly on this slide. Finally, you have the option to explore careers at NASA. You can choose to learn about one NASA astronaut by going to this bit.ly link. And actually, you should see a whole playlist of astronauts you can learn about next to this video. You can also go to this careers page on the NASA website. I want to give you a heartfelt thank you for all of the hard work you've done today. One last thing before we end. In your STEAM Camp journal, answer the following questions. What was the most challenging part of today?
Crashing into a wall.
I was actually asking the students.
Okay, fine. What career excited you most of the day?
Good question. How about, which career or careers involving math interested you the most when thinking about your tips, talents, interests, passions, and strengths?
That's what I said.
Students, go ahead and finish your thoughts in your journal, and we'll see you tomorrow. Thank you and have a great rest of your day.